Not today. Okay. Here is the stuff that you need to make sure is on the front of your periodic table. This is what we put on it last try and in the first try. So, what you see on the front here, ladies and gentlemen, you can start copying onto your periodic table. All right.
Mr. Brand, do you have pencils?
I don't, no. I have quit giving out pencils to upperclassmen. I figure that's the one thing you can bring to class. Caden, where are you? Thank you. I need to put you into a seating chart. Amelie, okay. Jose, where are you at? Where are you sitting?
Oh, no.
Thank you. Deacon. Alexis, thank you. Yasmin, gotcha. Good. Aiden, yep, gotcha. Maybe. Alejandro, yep. Michaela, gotcha. Evelyn, where are you? Sorry, that's why I can't find you because you're right in front of my face. All right, Alan. Nope, other one. Where's the other one? There you are. Now you, Alan, I got you. Michelle, thank you. Kayla, thank you. Maya. Tiana. Good. Crystal. Thank you. Monica. Thank you. Jasmine. Jasmine, don't you want a different seat where you can explore the world and see things from a different perspective occasionally? Okay, just checking. Lily. Yep. Get into that seat, Lily. There you go. All right. Adriana. Sorry. Thank you. Jordan. Okay, wonderful. Emmy. Gia. Adoption. Boom.
What is that? That's crazy. Because I think that ginger. Two-parted. Bro, I failed it both times. The first time I got like a 6%. The second time I got a 36%. Both times. Bro, I get 6%. I can't really stand her, bro. She's selling my shit so hard. I'm gonna fail the ACT because of her. Dude, I stayed after school every day for extra notes. I stayed after school almost every day, and I still didn't pass a single test. I think it was both tries. I didn't pass a single test. I took like 3 of them.
All right, here we go, ladies and gentlemen. By the way, who in here has Mr. G for a teacher? Anybody? Math? Mr. G? Do you? Okay. Well, supposedly he's the only teacher who does anything on the first day of a trimester, so I'm going to break that trend today. Here we go. Okay. Hydrogen can act as a metal or a nonmetal. It is in this spot right here. You should highlight it, ladies and gentlemen. As a nonmetal, which it normally is, it will have a -1 charge. Deacon headphones. It will have a -1 charge. However, it can act as a metal and be a +1 charge. And the reason for that is it only takes 2 electrons to fill the very first energy level. So by having 1 electron, it is half filled. So it is no easier for it to gain 1 electron than it is for it to lose 1, which is why hydrogen will act like a metal at times as a +1 ion, because it will lose electrons, become a positive ion, which we call a cation, ladies and gentlemen. Or hydrogen can gain 1 electron, become a negative ion, or what we call an anion. Okay? So, important note, important note, important note. This part about mass number equals protons plus neutrons, you will not need it this trimester. We're not going to break the atom down that way. You don't need to know that the number of neutrons is equal to the mass number minus the protons, because I'm never going to ask you that this trimester. You better know that the atomic number is equal to the number of protons. This entire periodic table from element 1 to element 118 is set up based on the number of protons in the nucleus of the atom. Questions? Now, the most important thing for us in this try is we need to understand how atoms get their charges, because again, we are going to be writing and naming compounds. Now, if you were lucky enough to have me in the last try, you are just coming off of this unit. If you are not lucky enough to have me last try, we are going to review some with you over this week. But here's what I'll tell you when we do the reviewing. I'm only going to allow so much time in class. If you need extra help, I am here during home base. You can literally come to my home base any day you want. Advisory period, whatever you want to call it. You come here. You don't need a pass. I don't need to flex you in. You come to my room. I'll send a note to attendance that says you were with me, and I will give you whatever help you need. You can come see me after school. You can come and see me before school. Other than that, there's no time you can come see me. So other than before school, during school, and after school, those are the only 3 times I have available for you. So if you don't understand what I'm saying and you still don't remember some of the naming stuff after the first few days of reviewing, come and see me. I will give you the individualized help that you need. Now, when we talk about the groups of the periodic table, there are 8 main groups, 1 and 2, and 13 through 18. Those 8 main groups are representative of the number of valence electrons that an atom has. Valence electrons are the outermost ones. I don't care about the innermost ones. The only ones I care about are the outermost ones, because those are the electrons that are involved in combining, in gaining or losing. Now, everything in group 1, including hydrogen, ladies and gentlemen, has 1 valence electron. 1. Now, you have 2 choices. You need 8 electrons to fill your outer shell. The 2 choices that anything in group 1 has is they can lose that 1 electron, or they can try to gain 7. Gaining 7 would be almost impossible, therefore they lose 1 electron. And therefore they have a +1 charge, and that is why under francium I have a +1 charge. Now, hydrogen can do this, but because hydrogen is also in the first energy level, and the first energy level is the only level that requires fewer than 8 electrons to be filled. It only requires 2. Hydrogen is half filled. So as easily as it could lose 1 electron, it could gain 1 electron to fill its outer shell. It's the only element that can do this. The only one. So from lithium on down to francium, those metals will always be a +1. Hydrogen might be acting as a +1, might be acting as a -1. We'll show you how to, or we will remind you how to tell over the next couple days. If you go to group 2 of the periodic table, from beryllium down to radium, those all have 2 valence electrons. 2 valence electrons means its options are this: lose those 2 or gain 6. Gaining 6 is not an easy thing to do. So instead they choose to lose their 2 electrons. When they lose their 2 electrons, ladies and gentlemen, they have a +2 charge. Okay? Now, These elements in here we're going to ignore for now. Why? Because they can have more than one charge, most of them. So we're going to ignore them. We're going to go to group 13. Now again, we're going to go from aluminum down to thallium. I will not give you any compounds that involve the man-made elements. They don't exist long enough to form compounds. So I'm not going to give you any. Okay? So from aluminum down to thallium, ladies and gentlemen, those have 3 valence electrons, meaning you either lose those 3 or you try to gain 5. Since they're metals, they find it easier to lose those 3. Now, there is one element that could possibly gain 5 electrons. What element is it? Boron. Boron, if we follow the pattern of negative charges up here, should have a negative 5 above it. Chances are that's not going to happen. Okay? Chances are boron, instead of making an ionic compound where it would have a negative 5 charge, it is going to be involved in a covalent compound where it will share its electrons, and we will talk about that a lot in Unit 8. Okay? Now we get into group 14. Now you've got 4 valence electrons. Now you're half filled. Is it easier to gain 4 or lose 4? The answer is yes. It's as easy to gain 4 as it is to lose 4. So therefore, ladies and gentlemen, the nonmetals at the top of this family, they will gain 4 electrons and become a negative 4 charge, carbon and silicon. But the metals at the bottom will still lose electrons. Why? Because that's what metals do. Metals always lose electrons. Now that means that from germanium down to lead, they should be a +4. Well, that is what we would hope would happen, but the reality is 2 of the elements, tin and lead, will sometimes act like a +2, sometimes act like a +4. And in Unit 8, when we talk about electron configurations, I will explain why that is possible and how that is possible. And it also then explains why these can have more than one charge. But that's a long way off. So I would make a note in here that while these are +4, they can also be +2s. Okay? Just these 2, not germanium. Okay? Now we get into the nitrogen family, ladies and gentlemen. And what I'm talking about is nitrogen, phosphorus, and arsenic. They have 5 valence electrons. You could lose those 5 or you could gain 3. Much easier to gain 3, which is why nitrogen, phosphorus, and arsenic have a negative 3 charge. Now, if you had to write an ionic compound with antimony or bismuth, what charge would they have to be? They would have to be a +5. I don't think I've ever given anybody any compounds with antimony or bismuth in them. Acting as a +5 could happen, though. The oxygen family, oxygen, sulfur, selenium, and tellurium, now have 6 valence electrons. Meaning, if they gain 2 more, they will become stable. Or they could try to lose those 6. Isn't happening. They're not losing 6 electrons. So they become a -2. If anything were going to be a +6, it would be polonium. Again, I'm not going to give you compounds with polonium in them. We get into the halogens, better known as group 17. Fluorine, chlorine, bromine, iodide, astatine. These ones here, ladies and gentlemen, have 7 valence electrons. 7 valence electrons. Therefore, they only need to gain 1. And that is what they will do, ladies and gentlemen. They will gain 1 electron. Okay? And they will become stable. Just like group 18, which doesn't gain or lose any electrons. Group 18, the elements are stable. They are monatomic, they are inert, they are unreactive. All meaning they're not combining with anything. Why? Because they have their outer energy level filled. And they do it by already having 8 electrons except for one element. What element does not have 8 electrons and yet it is stable? Good, thank you. Helium. Helium only needs 2 electrons to fill the first energy level. It has to. It is stable even though it does not have 8 electrons. Questions? Okay. I'm not giving you the Roman numerals and I'm not giving you the prefixes anymore. So if you don't have those written on your periodic table, now would be a dang good time to do it. These down here, 1, I in a Roman numeral, mono in a prefix. 2, I in a Roman numeral, di in a prefix. 3, I in Roman numerals, tri in a prefix. So on and so forth. Please copy those down. You may want to come up and grab a highlighter for this next one, ladies and gentlemen. And if you did not grab a green sheet and a white packet, since I saw some of you starting to do that, please come up and grab them. That way I don't hand you two if you already have one. All right. The 7 elements that I need you to highlight, ladies and gentlemen, are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Does anyone remember why we are highlighting those? What's special about them? They are what are called the diatomics. They are called diatomic molecules, which means if you are ever writing a balanced chemical equation, which you will be doing in this trimester, and it has hydrogen gas being created or hydrogen gas as a reactant, hydrogen gas is written as H2, never H, H2. In a compound, there can be 1 hydrogen. There could be 2 hydrogens. There could be 3 hydrogens. They have to be balanced off. Alone, you will always write H2, just like you will always write N2, O2, F2, Cl2, Br2, and I2. You will never write the element bromine with the symbol Br. It always has a 2 by it. You will never write the element iodine as just I. It has a 2 by it. Okay? Now, again, in a compound, we will balance off charges, which I will show you in a moment. But when these are alone, if iodine is a product or iodine is a reactant in a chemical reaction, it has to be written as I2. It has to be written as Cl2 if it's chlorine, Br2 if it's bromine. Okay? Questions? Bad flashbacks, Lily, or what? The quiz on Friday. Okay. This quiz? Oh, don't worry about it. That has nothing to do with this. We're going to quiz you on the stuff you're about to learn, not the stuff you should already know. Okay? All right. Let's see. By the way, those of you who I had first try but not second, I asked second try to add 1 polyatomic to the front side of their periodic table, and that is hydroxide right here. I would write this on the front side of your periodic table, ladies and gentlemen. Why? Because it is one of the few polyatomics that ends in IDE. And if you don't remember what a polyatomic is, turn your periodic table over and look at the back side. There is a list of about 20-some different polyatomic ions on the back side of your periodic table. A polyatomic is a group of atoms acting as a single ion that are covalently bonded together. Most of them on the back of your periodic table have a negative charge. There is one that has a positive charge, and that is ammonium, NH4. It has a charge of +1. Ammonium is the reason we will use the term cation at times. A cation is a positive ion. All of the metals on the periodic table form positive ions. So normally we can just say metal. However, ammonium is not a metal, but it is a positive ion. So we say cation. The negative ions over here on this part of the periodic table, ladies and gentlemen, are also called anions. However, in a lot of compounds, you have a polyatomic ion that has a negative charge, like these ones listed on the back here, ladies and gentlemen. And when they are in a compound, we use the term anion because they are not just a nonmetal. They are a group of nonmetals bonded together. Now, all of them end in ATE except for the ones that are highlighted on the back side of your periodic table. Well, here's the good news. I don't think I've ever given anyone in my classes a compound with cyanide in it. I have never used ferric cyanide or ferrocyanide. We do use hydroxide a lot, and that's why you just put it on the front side of your periodic table, because it is the one polyatomic that ends in IDE that we will use in this class. Questions? Wow, you guys are doing awesome. Absolutely awesome. Now, just as a reminder, ladies and gentlemen, a polyatomic like chlorate, ClO3. A polyatomic like chlorate, ladies and gentlemen, can change the amount of oxygens in that compound. Anything that ends in ATE can change the amount of oxygens in that compound. And that is where these boxes on the left hand come from. Okay? Chlorate is ClO3. It has a charge of -1. And when you put it into a compound, we are going to create a compound that has a total charge of what for ionic compounds? Snapping your fingers is not the answer. What? 0. All ionic compounds have a total charge of 0. Now, here's the interesting part, or here's the good part for you. If we take something like chlorate and it changes the number of oxygens, so instead of 3 oxygens, there's 4, or there's 2, or there's 1. Even though it changes the number of oxygens, it does not change its charge. Chlorate always has a charge of -1. However, ladies and gentlemen, chlorate could be written as ClO2 -1. This, ladies and gentlemen, is chlorite, following the rule set up here, which is if your polyatomic loses 1 oxygen, we will change the ending from ATE to ITE. So chlorate, which is ClO3, becomes ClO2 when it loses 1 oxygen, and because of that, we will change the name to chlorite. Okay? Now, chlorate could lose a 2nd oxygen and become ClO. Still a -1 charge. Now, if you're sitting there going, wait a minute, how did that lose 2 oxygens? How many chlorines are in this compound? 1. If there is no number by your symbol, it means there is only one of them there. This was 1 chlorine and 2 oxygens. This is 1 chlorine and 1 oxygen. This is 1 chlorine and 3 oxygens. 3 minus 2 is 1. I just don't write the number now because we never write ones in formulas. So this has now lost 2 oxygens. To change the name, we put hypo in front. So it becomes hypochlorite. Still an ITE ending, but hypo in front means you have lost 2 oxygens. Questions? Well, if that wasn't bad enough, ladies and gentlemen, you can gain 1 oxygen. And if you gain 1 oxygen, so ClO3 becomes ClO4, we put a prefix of per in front, and we leave the name as it was. So perchlorate. All of that is explained in these 3 boxes on the back of your periodic table. Questions? You will be using this every day in class. Every day. For at least the next 3 units. Okay? And by the way, ladies and gentlemen, just like in the first trimester or the second trimester, whenever you had, we did unit 1, 2, 3, and 4, we're doing units 5, 6, 7, and 8. Okay? Each unit will be roughly about 3 weeks. This unit will be over by the time we go off on spring break. I will make sure of that. Okay? The one thing I will tell you, ladies and gentlemen, you're going to need to grab a calculator just about every day. Because units 5, 6, and 7 are a whole lot of math. A whole lot of math. Okay? Unit 8, no math. But 5, 6, and 7, a lot of math in those units. Questions? All right, so let's talk about using this to make a formula. Now, here's the good news, ladies and gentlemen. When you look at that green sheet that you came up and took off of the desk, the green sheet is a review sheet. We are going to do the top 2 boxes on page 1 and the top 2 boxes on page 2 today. We are going to do binary ionic compounds and we are going to do ternary ionic compounds. Somebody remind me what binary means. 2. Binary means 2 elements. These compounds only have 2 elements. In an ionic compound, one is a metal and one is a non-metal. Binary ionic compound is between a metal and a non-metal. Okay? Now, ternary ionic compounds have at least 3 different elements in them. They may have more, but at least 3. And the only way you can write a ternary ionic compound is to turn your periodic table over and find the polyatomic ion that is involved. Okay? Questions? Now let's go back a minute here because I should have mentioned this earlier when the periodic table was up there. By zinc, I hope you wrote that zinc is a +2 on your periodic table. If you did not, in the box for zinc, please write that it is a +2 ion. You put that tin could be a +2 or a +4. You put that lead could be a +2 and a +4. Zinc is only a +2. Silver, just below it and 1 to the left, is a +1. So please write that by silver, that it is a +1 ion. Okay? Now, if I were to ask you the charge of most elements, you can find it by knowing what group it's in. So if I ask you for the charge of magnesium, because magnesium is in group 2, it's a +2. If I ask you for the charge of sodium, because sodium's in group 1, it's a +1. If I ask you for the charge of oxygen, because it's in group 16, it's a -2. I cannot do that with these transition metals in here. Other than zinc and silver, I cannot ask you what their charge is, and you're able to identify it based off of where it's at in the periodic table. Can't do it. So I will have to give you those charges. The way I will give you those charges is in the name, we will put a Roman numeral right after the metal. Roman numerals only go in between the two words. They never go at the end, and they never go at the beginning. This Roman numeral right here is telling you the charge on this iron. Okay? So that is where you will find the charge on something that is in here. Is when I give you the name, I have to give you the charge. Now, again, 99% of the time in this unit, in Unit 6 and in Unit 7, I will be giving you names and you will be writing formulas for them. Okay? Very rarely, if ever, will I give you a formula and ask you to name it. All right? So let's take these names and write formulas for them. So let's begin with iron 2 nitride. So first thing we do, ladies and gentlemen, is we write the symbol for iron and we write its charge. Iron is Fe. Its charge is a +2, and this is because of the II there. That's how I know the charge. I can't go over to the periodic table and look at it. Okay? Now, nitride, ladies and gentlemen. Nitride comes from nitrogen. Let me get rid of all this stuff. Okay? Here is nitrogen. IDE ending means it's a binary compound 99% of the time. 99%. Not always, but normally. Nitride comes from nitrogen. Nitrogen has a -3 charge according to where it's at on the periodic table. So I'm going to put it with nitrogen and a -3 charge. Now, this is an ionic compound. How do I know? It's between a metal and a nonmetal. Iron is the metal, nitrogen is the nonmetal. Therefore, I need a compound that has a total charge of 0. The way we achieve this, the easiest way to achieve this, is we do something called the crisscross method. The crisscross method says I'm going to take this 2 from up here by the iron, and I'm going to put it by the nitrogen. I'm going to take this 3 from up here by the nitrogen, and I'm going to put it by the iron. And my formula looks something like this. Fe3 N2. That is what my formula looks like. Now, the crisscross method never fails to get you a compound with a charge of 0. Never. By doing the crisscross method, you will always end up with a total charge on a compound of 0. Let me show you. Because what this compound here really is, ladies and gentlemen, is it is this. It is these 5 atoms in one compound. 3 irons, +2, +4, +6. And 2 nitrogens, -3, -6. +6, -6, 0. That is what this formula tells us. There are 3 of these and 2 of these together in one compound. That is the formula for this substance. Your charge is 0. Never fails with the crisscross method. But there is one way the crisscross method does let you down. What is that? In an ionic compound, we must reduce into lowest terms. The 2 elements, or the element in the polyatomic that are there, must be reduced into lowest terms. That is the only way to write an ionic compound. And that is the one thing that the crisscross method will not do. It will not put your compound in lowest terms. So if your compound is not in lowest terms, you need to reduce it. Well, you cannot reduce 3 and 2 into smaller whole numbers. But let's do the next one. Germanium, give me the symbol and its charge, please. Someone. Ge plus 4. Oxygen, give me the symbol and the charge. So when we do the crisscross method, this 2 comes down by the Ge, this 4 goes down by the oxygen, we get Ge2O4. Now that has a total charge of 0, absolutely. But it is not written in lowest terms. This 2 and this 4 can both be reduced by 2. And we have to do that. Which means the formula is GeO2. Reducing your formula down into lowest terms. Questions? Not bad for 12 weeks gone from this that you don't have a single question. I mean, it just feels like 12 weeks for you. I know. But the person sitting next to you, it's been 12 weeks. Okay? Okay, if your compound ends in ATE, I guarantee you there's a polyatomic in it because that's the only way your compound can end in ATE. If your compound ends in ITE, there has to be a polyatomic in it. If it ends in ID, may or may not involve a polyatomic. So, ammonium sulfate. Formula for ammonium, NH4. Charge +1. One of the very rare positive polyatomics. Sulfate is the last element on the bottom of the backside of your periodic table, and it's not an element, it's a group of elements, and it is SO4, and it has a charge of -2. So I am going to take this -2, just the 2 part of it, and put it by the NH4, and the 1 part here is going to go by the SO4. So I put NH4, but before I can put this 2 by it, what do I have to do to it? I have to put any polyatomic that I am going to put a number by it in parentheses. So because I am going to put a 2 by that NH4, I need to put it in parentheses. Okay? Now, the SO4, what number is going to go down by the SO4? A 1. Do I write 1s? So I do not need to put the SO4 in parentheses. Why? Because I'm not putting a number by it. We put the polyatomics in parentheses so we do not ever change the group. That is the only way to make sure the group never changes, is to put it in parentheses. Now, in the NH4 here, how many nitrogens? 1. How many hydrogens? 4. People, for some reason, think that this 4 sometimes goes to that end. It does not. They are 2 separate elements. Every capital letter is a new element, ladies and gentlemen. Sometimes you will put numbers by them, sometimes you won't. Okay? We did not put a number by the GE here. Why? Because there's only 1 of them. We did put a number by the oxygen. Why? We wanted to represent 2 of them. Here, 1 N, 4 H's. 1 S, 4 O's. Now, we put that NH4 in parentheses and put a 2 by it. What does it do to the amount of nitrogen and the amount of hydrogen? It will double them. This 2 will distribute out to both of these because it's distributing out to the group and saying, I need 2 of these groups there. I need 2 of these groups to balance off 1 of these. That's why it's in parentheses with a 2 by it. Okay? All right, calcium, symbol and charge. Somebody please. Ca plus 2. Hydroxide, symbol and charge. Take this 2, bring it down by the OH. Take this 1, bring it down by the Ca. I never write ones. If I'm going to put a number by a polyatomic, what do I have to do to it? Put it in parentheses. Even hydroxide, which does not have a number by the H, the group goes in parentheses. Always. The group goes in parentheses always. Questions? All right, ladies and gentlemen, you now have 15 minutes to do the top 2 on this page and the top 2 boxes on the next page. Actually, I should say the top 4 boxes. Get as far as you can in 15 minutes. Answer keys are out on every table behind you, ladies and gentlemen, sitting on the corners, waiting for you to use to check it. In 15 minutes, I will show you the answer to these 4 boxes here and the 4 boxes on the next page. And then tomorrow, ladies and gentlemen, we will talk about acids and binary compounds. So, giving you everything you need, you now have 15 minutes, ladies and gentlemen, to get done what you can. Go. If you need help, if you have questions, you can ask. If you want to go in back and work at the lab tables, the chalk markers are still out there. The towels are in the middle. You are more than welcome to do so.
Hey, Emily.
Yes, I can. By the way, if you're not sure of how to do the Roman numerals, I will show you afterwards. Write the name without the Roman numeral, and I'll show you how to figure out what the Roman numeral is. This, and this. You should be able to do. Except you're going to need a Roman numeral in there that I'll show you how to do. Correct. I'll show you how to do that. Well, I don't know if it's a letter 2 or a letter 4 in that compound. How do you know it's a 2? That is not how we know. I will show you how to do that. I will remind you that. Just move on to the next one, and I will show you how to figure that out. Okay? It's one of the 2. What I'm saying is, don't get hung up on that right now. Move on to the next one because you're doing good. I don't want to confuse you with doing that. I'll show you that when we're all back together as a group, so I don't have to show you and then the last person. Okay? All right? I will go over how to figure it out. Yes. Okay?
What? What did you That's crazy. From Mercury, Andreas does it all the time. He like mocks me because of this thing.
I don't know what we're talking about.
What was that one thing you said? You were like, I mean, the only thing stopping me from like murdering you is the desk.
No, it's a law.
It's the law. Yeah, the law. That's what it was.
The only thing that stops me from killing most of you is the law.
But like you just said it out of nowhere. It's just my name.
Well, because I was talking about you. If I was talking about Tiana, I would have said Tiana. The only thing stopping me from killing you is the law. See, I'm a law-abiding citizen. You're lucky. If not, I'd have a lot fewer
You'd be lucky too.
Why?
Because I'm a law-abiding citizen too.
That really doesn't matter if I do what I was thinking about doing.
If I did what I was thinking about doing. So everyone.
Yeah, but do you have a way of getting rid of the body with the right chemicals?
I do. Yeah, I take notes from you. Yeah. You scare me. Disposing, talking about some disposing the body with chemicals.
Or there's lots of tunnels down below the school.
Oh, really?
Really?
Is that where you put
Supposedly there's tunnels that go all the way to Washington. I've never proven it.
Is that where you put the students?
Tunnels that go all the way to Washington.
Some, maybe.
Let's go for a little adventure.
Only because I had it blocked.
That's nice. That's nice.
Friend of mine, Deacon, who's blocked out how to write compounds on his memory completely. Well, good, then get it done and show me that you could actually do it.
It's the first floor.
Okay, you do realize and that's why it says formulas highlighted in gray require the Roman numeral.
So we define that.
That's not actually fine print, that's bolded and right up in front.
Wait, so it's
We will show you how to do it if you don't know how to do it.
He just made it. He really did made it.
Yeah.
Are we?
We are first.
I don't know anything about this one. I just made it.
Nope, that's in later. That's in this unit though, you're gonna be puking. Why? Yeah. Yeah, you are. It's this unit. You see out there.
I took one.
It's always the metal. It's been a long time to do that. I will show you how to find it out.
I don't do the voice.
I did not have to do it for everybody. Okay? Now, as long as you're talking about stickets to bed, try to get your answers. No, the answer doesn't, the reaction does. And we have a stronger reaction this student.
Okay.
Yeah, that's what you do. I mean, hey, sir, so like, how much longer do we have in this phone?
Okay, put away your phone.
I was gonna ask you to charge it.
Where's that coming?
How's it dead this early in the day?
No, that's really bad.
Do you not charge it at night when you
listen,
sleep?
listen. I woke up at
I'm
like,
trying not to
what happened
listen.
your purple cup?
I got a new one.
No, he's been drinking it. Anyway,
Why?
This is what happened, sir. So I woke up at like 4 o'clock, right?
Besides, here's my purple cup.
And I had to watch Netflix and I was getting ready.
You had to. Yes, I understand. That's a rule for you guys now. As teenagers, the rule is you have to watch Netflix when you're doing things.
Yeah, while I'm getting ready in the morning, you know? I had to catch up on my show. Oh my god, I started this new show. It's so crazy. I lost my drawing room. Oh wait, look at, you see the breaking sign? Right? Andre. Actually, I have to buy it. Where's Chromium?
Your locker in your backpack. IDE. Even though it's just fluorine, when it's just fluorine at the ending, it's fluoride. Still end in IDE. And that is again by some of them that end in IDE, maybe ternary, but they don't end, or they still end in IDE like binary. Right?
Tanaya?
Always call him
7.5 minutes to get one done.
Oh,
Sorry. 8 minutes and 15 seconds to get one done. Yes, please, log in real quick. I love that. So far, every time I try to stop, it's worked. But I'm really beginning to wonder because I heard you work.
Literally ever since then. You know, Brad always texts me, bro. This dude's always texts me. He's like, when's the trip? What's coming back? I was like, I missed her. I'm just joking, of course. She would always fuck with me here.
I don't know.
But I just felt like, I don't know. He was like, yeah, I just feel so comfortable. Because like, he is the only thing he ever does. My mom slapped me when I punch me. That's all he does. Every time. He's like,
Now you might use it. How we doing?
I don't feel like doing anything.
Which one?
Wait, that's the one at the top, right?
It's almost like you didn't. But you're one of the lucky ones. Sorry.
Mr. Brandon.
Wait, we need to put the
Tiana.
This masterpiece. You're trying to say my name right.
I'll mess it up at some point, don't worry.
Print this out and put it on your wall.
First of all, it's your computer. How am I supposed to print out something that is on your
I
computer?
emailed it to you.
When?
What, first trimester?
Yeah, but I have you blocked as far as any emails coming to me go.
I'll start again.
How are you?
Christopher Brand.
Sick? That's a terrible thing. It's a terrible thing.
Why your profile picture everything?
Because I don't want anybody to see what I look like. I'm scary enough in person, let alone online.
Wait, if you're not an editor, can you still copy it?
What?
If I don't make you an editor, can you still like?
Yeah. Well, here's the thing. If someone sends you something in Google, you can always make a copy of it and then do whatever you want to it.
Okay, I don't feel like
What's that? Oh, that's your choice. What's that? Sure.
Those ones are easy peasy.
it's just more binary.
Easy peasy, lemon squeezy. Of course.
This part, but once you start adding that math stuff into it, you're gonna be okay.
Ooh, don't worry, we're gonna mess you up big time. man.
Yeah, we know.
This is like the math.
You're forgetting 92 and the 90
Math.
because a compound always, a binary compound's always in the 90s. Chlorine becomes chloride, carbon becomes carbide, hydrogen becomes hydride.
I had to do the entire time.
Normally you go back to where it makes sense, like you don't go hydro I, you go hydride. Okay, back to the R. For carbon, you go carbide. And for chlorine, you change the M to a D. That's just IUD. Sulfur, you go back to the sulfide. So you go and then IDE. By the way, you got about 3 minutes left. The ones you should be concentrating on are on the second page, ladies and gentlemen, where you're writing those formulas, because those are what you're going to do a lot more of this year. That's what I think. What?
You make me cry.
I made you cry? What did I do? Hold an onion under your nose? Or?
No,
This math.
Well, I don't know how I get blamed for certain things.
right, Mr. Brandon?
I got real salty when I
Say
said
right.
that.
No.
Yes. You agree with it.
If you tell me what it is, I might.
If you're going to say soccer's a sport, no, I'm not going to agree with that.
Boy, get out of here. Basketball's not a sport.
Really? It has the second hardest thing to do in any sport or activity.
Run back and forth and dribble the ball.
No, throw a ball up into the air, into a hoop that's only twice the size of the ball that's going the wrong direction. I can put a 3-year-old in front of a goal, put the soccer ball down, and it'll kick it into the goal.
Not very hard. With a
Doesn't
goalie-
matter.
with a goalie-
I didn't put Shaq guarding you while you're shooting the basketball, did I?
But somebody's gonna be guarding you.
No.
Your butt.
The second hardest, again, I'm talking about just a hard thing to do in a sport. It's difficult to make a basket in basketball. Now, get to work. Again, you can be wrong in your opinion, and you're entitled to it. That's fine. So,
Pro coaches girls basketball.
if you ever compare me to Mr. Kalo again, you will not survive my class. And I'm talking literally, I will be willing to break that one law that I will normally not.
Oh really? The murder one? I get a lot.
I never said murder. I said killing you.
Same thing.
No, could be justifiable homicide.
Justifiable. It's still homicide. It's still homicide.
Well, then you shouldn't have come back.
I think she would. But against her will? Okay.
Life is full of choices. You chose to make one.
You're so inspirational, Mr. Brown. Hello, boy.
Deacon, sorry you can't get that second one done because the next 6 minutes has gone by. All right, come back to your seats, ladies and gentlemen. Hurry up. Let's go. Let's go. Let's go. I got more to do. I got some stuff to get through, and you are slowing me down. I understand that, and I got 20 minutes of stuff to do in 13 minutes, and I can get it done.
Oh, we only got 7 minutes. I can go eat lunch.
I don't know what you're doing telling time, but it ain't good.
Isn't your class at 37?
No.
What time is it at? 38, 38.
Look at the wall or at the glass. All right. So here is what the front side should look like. Now, for Roman numerals, ladies and gentlemen, please remember, the total charge on any ionic compound is always what? Total charge on any ionic compound is always what? 0. And we may not know the charge of the metal, but we will always know the charge of the non-metal. So in this compound, I know the charge of carbon, and I know the number of them. What is the charge of carbon? Yes, -4. Thank you. How many of them are there here? Yes, there is 1. 1 minus 4 means a total charge of -4. Which means we need to balance that off. Put those away, then you won't even think about putting them on again. Which means the charge of the tin has to be a +4 for the total charge to equal 0. Now, again, the question is, what is the charge and how many of them are there? Well, I know there are 2 because of the 2 there. What charge times 2 gives you +4? A +2. That is where the Roman numeral of the 2 comes from. Okay? That is where the Roman numeral of the 2 comes from. Here, ladies and gentlemen, PV, CO2, 2. This has a charge of -2. And there are 2 of them. That means a total charge of -4. Okay? There is only 1 of these. The total charge here has to be a +4 to balance off that -4. So if there's only 1 of them, what has to be the charge of it? We want a total charge of +4. There is only 1 of them here, though. So the charge has to be a +4. Thank you. That is how you will find the charge. Now, here's the good news. you probably won't have to do that at all this trimester. Instead, I will give you the formula, kind of like these, where we are going to give you the name and you are going to write a formula. And you need to know that that Roman numeral of 3 means the charge of iron is 3. Questions? Take out your computers. Open up to the Canvas page for this course, please. Yes. They're right up here. Okay, ladies and gentlemen, I don't know if it is true or not, but I'm pretty sure this is true. First time ever, ladies and gentlemen. In my 3rd trimester of teaching, I have 4 classes that are exactly the same. I have 4 Chemistry B classes. So my 1st hour, my 3rd hour, my 4th hour, and my 5th hour are all the same. And I don't know if that's going to be good for me or if that's going to mess me up in ways that I can't recover from. But what I want to let you know is that if I start talking about something and you're like, Mr. Brand, you finished up with that yesterday, let me know. Or if I start talking, there seems to be a gap, please let me know. Okay, daily agenda and class videos. Again, this is still out there. If you missed a day of class, you can find out what we did that day and you can see the video from the class that day. So please also remember, if you say something mean about another teacher or Miss Lip, it goes on YouTube. So it's out there for them to find. Here is your periodic table front and back. Here is that pink reference sheet or that salmon colored reference sheet that we will be using this trimester as well. Down below, Unit 5, the mole. That is where we are at, ladies and gentlemen. Here is your EISN. Here is the master EISN. And here are the answer keys to all the worksheets that I've given you in that packet. So if you would, please open up to that student EISN. The unit is the mole, ladies and gentlemen. Okay? We already talked about the mole. It was one of the 7 base units. You have already been introduced to it. Now you're going to learn how to use it. Okay? So, these are the topics that we are going to cover. The mole, formula mass or molar mass, converting into the mole and out of the mole, finding empirical formulas, finding percent composition, ionic compounds in water, and ionic equations. And again, we will be done within 3 weeks because when we start spring break, this unit will be over. So the mole, ladies and gentlemen, mole means amount of substance. It is a term. It is like saying you have a dozen of something. If you have a dozen of something, how many do you got? 12. It doesn't matter what it is. You got a dozen eggs, you got 12 of them. You got a dozen golf balls, you got 12. You got a dozen pencils, you got 12. Dozen means 12. Mole means 6.02 times 10 to the 23rd, which means it is still an amount. It is just a very large amount, ladies and gentlemen. A very large amount. And the scientist who gave us this idea was called Avogadro. Okay? And we call it Avogadro's number, 6.02 times 10 to the 23rd. No one has ever counted to 6.02 times 10 to the 23rd because it would take longer than a lifetime to do so, ladies and gentlemen. Ever. But the idea and the concept of the mole is that this number describes when you have a certain amount of something. Okay? Now, up here in the front of the room, ladies and gentlemen, I have some elements and I have some compounds. And guess what is the same about each and every one of them? Yep, you got it, ladies and gentlemen. They are all representing 1 mole of that substance. This is 1 mole of lead. This is 1 mole of magnesium. This is 1 mole of water. This is 1 mole of iron. Rusty iron, but iron. This is 1 mole of glycerin. This is 1 mole of lead. This is 1 mole of zinc. So is this 1 mole of zinc. This is 1 mole of copper. This is 1 mole of salt, like you would put on your fries. This is 1 mole of sugar, like you would put in your coffee. And this is 1 mole of a different kind of sugar called dextrose. Every single one of these things, there is the same amount of each one of them here. They are not the same mass. They do not occupy the same amount of space. What is the same is that for every one of these, there is one of these other things here. All the way to 6.02 times 10 to the 23rd. If you had 3 ping pong balls and 3 bowling balls, would they occupy the same amount of space? Not even close. If you had 3 ping pong balls and 3 bowling balls, would they have the same mass? Not even close. But what you would have is you would have the same amount of each. That's what I have here, ladies and gentlemen. I have the same amount of every one of these things. Okay? And it goes back to something called Avogadro's law. Equal volumes of a gas under the same set of conditions, meaning pressure and temperature, which is unit 6, ladies and gentlemen, will contain the same number of pieces. Avogadro gave us the idea that if you have something as a gas and it occupies a certain amount of space, that determines how many particles are in it. And it doesn't matter what the gas is. Can be methane, can be ethane, can be propane, could be carbon monoxide, carbon dioxide. Any gas that occupies the same amount of gas as any other under the same conditions means that there are the same number of pieces there. The exact same number of pieces there, ladies and gentlemen. This is called the mole concept. For the next 3 units, if you are given a problem and you have no idea how to start it, get it into moles. Get it into moles, because moles will allow you to go wherever you want. Wherever you want, you can get there from moles. Okay? So this, ladies and gentlemen, is something that you may want to copy into your notes, but I want to warn you, in your notebook, these 2 arrows are flipped around. So if you click on them and take the handle, you can rotate them either 90 or 270 degrees, and you can get them so they're pointing in the right direction, because then they will look like that poster up here, which, by the way, will not come down during tests or quizzes or things like that. So if you like that seat in the back way over there where you can't see it, stay with it. But on test day, you may want to, try to bump Crystal out of her seat here. Okay? Or you could simply put it on your periodic table, ladies and gentlemen, because you could still use that on a test. Okay? So, what we are saying here is the mole is the central unit. Now, in this unit, I'm going to give you information 3 ways. I'm going to give you particles, I'm going to give you volume, or I'm going to give you mass. Now, here's the nice part about particles and volume, ladies and gentlemen. Particles and volume, you use one number to get in and out of volume in moles, and that number is 22.4 liters. 22.4 liters will get you into moles or out of moles, depending on if you put it on the top or the bottom of your fraction. Particles, mole, and 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd over 1 mole. The only one that is different, hey, I'm not done yet, is right here, mass. And the mass, ladies and gentlemen, depends on the formula of the substance. So guess what? You can't write those formulas that I just gave you. You can't find the formula mass. You can't find the formula mass. You cannot convert from moles to mass or mass to moles. So those formulas that you may or may not be good at, those formulas that you may or may not be worried about, you better be able to do them, ladies and gentlemen, because if you can't, you are in trouble. Questions? Look at there. I got 30 seconds left, ladies and gentlemen. 30 seconds left. If you took anything that doesn't belong to you from up front here, like a highlighter or whatever, bring it back.
Can I please get my cellular device?
Tomorrow, ladies and gentlemen, when you come into class, grab a calculator. You're going to need it. Goodbye, goodbye, goodbye. Thank you. Thank you.
Come on, Abby.
See you later, alligator.
Don't talk to me like that. That's not nice. Goodbye. 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 Yep. I'll take the markers. Thank you very much, sir. Wonderful. Yeah, I'm going to take care of that right now. Did you want it? No. Okay, me neither. Who knows where it's been?